Hello, everyone. Welcome back to another episode of Manufacturing Matters podcast, where we talk about automation, manufacturing, and other technologies. Joining me today is Winn Hardin and myself, Dan McCarthy of Tech B2B Manufacturing. Joining us is Patrick Iulianello of AccuCoat Technologies. We're recording, by the way, from SPIE's Photonics West, where Patrick is meeting us. Welcome. Patrick, welcome to the show. I'd like to
Good morning.
learn a little bit more. Yeah.
Really appreciate it. Busy day, I know.
Yep. Yeah, the show's very busy today, so we'll keep you very quickly.
Sorry.
Tell us a little bit more about AccuCoat and a little bit what you do. You're not an optics manufacturer on the coating side, so...
AccuCoat is strictly coatings for optics. We've been around 25 years supporting the precision optics world, anywhere from polymer, glass, crystals, and infrared materials. We have a niche in custom coatings and polymers because of the durability, and particularly in the military and the medical applications, for lightweight and applications with long-term durability. Our biggest market this year is for the focus on the infrared materials, the chalcogenides, the germaniums, the silicons for the infrared. A lot of military applications, but there's a lot more commercial applications coming up by the day.
It's funny because I was just at the A3 Business Forum last week, and we were talking with a number of camera manufacturers at that time, specifically in imaging space, machine vision, computer vision, some defense related, and we were talking about the growth and chip prices coming down on thermal cameras and sensors, and how we're finally going to make that pivot point where we can start moving to more volume deployments.
Yes.
I think, and I know we're going to talk about LiDAR and AR, VR down the road. So one wonders if autonomous mobile vehicles or mobility solutions might play into that a little bit.
Oh, absolutely, they will. We actually, one of our largest applications a couple years ago was in the LiDAR world. Not from the infrared coatings, but a 905 nanometer coating, a protective lens for the camera systems on top of the vehicles. And a lot of them you see on the mapping vehicles or the driverless vehicles that are currently out there now. We did a lot of the application on a cylinder lens to be able to put an anti-reflective coating all the way around a cylinder 4-inch lens uniformly. And to meet their specification, which predominantly was optical specification, but also cosmetic specification of a blue image.
Right.
They wanted a blue appearance and they wanted consistent on every part. So we developed a whole process for that application and probably did 10,000 parts that first year.
Wow. For
a camera lens protection. That's all it was. It was just a cover lens.
And because this is a show about manufacturing, I'd like to ask you, a lot of people could view people downstream, the integrators, the assembly makers, could view optics as a little bit more of a component technology, a little bit of a commodity. Tell us why that might be a mistaken perspective.
A lot of times it is considered a commodity, but a lot of the applications need a custom design, custom form, shape, and the coating design to go with it. Our coating, basically, an anti-reflective coating will improve the laser or optic performance like 10 or 20% transmission, depending on the refractive index of the lens. And that's where it really enhances the performance of the system, or get rid of ghosting from extra reflections, special beam splitters for imaging, things like that.
Could you give us an example of an application in which this complexity really kind of bears out? They talk about the machine, the optics, but you're on the coating side. Talk to us a bit about the complexity of that. I mean, I know it's not one step where you coat and you're done.
So one of the more complex applications we do is a cylinder or a polygon kind of application. So think of it as a 4 or 5 inch disc, maybe an inch thick, and it has multi-facets on the outside, like a spinner. And we actually developed a process that can spin the optic around a spindle, but also the spindle is rotated around the machine at the same time, kind of like an orbit, so that we're uniformly getting all the facets at the same time to get the high performance that they need uniformly across 24 facets that are on there. So it's a very unique application. That application is more for space guidance and imaging and things like that, but it can be used as simple as a barcode scanner at your retail store. They have polygons down there all the time, but those are your low-end polymer optic spinners.
Those components came up in a recent Photonics Spectra article on
they did.
Metallic coatings?
Adapting metallic coatings.
Okay.
We were a big component of that. that article that was done about the necessity of metal coatings or reflective coatings, because aluminum, gold, and silver coatings can be in the 90% reflective, 98, 97. Where also we do dielectric coatings, which has no metals in it. It's a combination of dielectric materials.
Yeah.
And we have one application that was mentioned in the article. It's for 3D printer laser.
Wow.
And it gets 99.9% reflection at the wavelength that they need. And with the metal coating, you're reflecting all that light and not losing anything through the optic.
Wow.
And that's a function of the coating itself.
It's a function of the coating. That's one application that the customer came to us with roughly a 92, 93% reflection. And we enhanced it to 99, and then also lost the light that was going through that was damaging the system on the other side. So they're able to reflect all that light and not have the heat damage going through.
So you were saying that was part of a 3D
3D printing application, the mirror that's in the system.
Right on. As a laser sintering type approach?
Yes.
Or okay,
Yes.
I wasn't sure if we were monitoring plastic or if we were actually executing using the laser to create the object.
And in terms of your capabilities, I know we talked about what you do. Talk to me a little bit about the machinery that's on your floor. So, I mean, what are the processes and techniques, and how is that?
Well, from the beginning of it, we have cleaning processes. We either do manual cleaning, or we also have ultrasonic cleaning for certain materials and applications. But we also the big applications are done through vacuum chambers. So we have vacuum chambers, a variety of different types, mostly E-gun and ion source deposition. We apply a variety of chemistries to the optics for the customers to meet their demanding applications. And they could be very thin. We're talking angstroms thick coatings or very thin coatings. That's why we're called thin film coatings. We do not add. A lot of people think coatings can fill the voids, the cracks, the chips. No, we don't. We're not the paint. We're just thin film coatings. And we
optical caulk. There's always an opportunity.
Optical caulk. So if it's there, we're probably going to enhance it rather than fill it in and make it go away. So vacuum coatings will go down 10 to the minus 6 torr.
Wow.
And a typical process, let's say a polymer optic, we could load a machine up with 500 to 1,000 1-inch parts. We could pull vacuum, apply the coating, open it back up, probably within an hour and a half to 2 hours, once it's set up and running on a regular basis. Is it usually a
single-step process like that, Patrick, or are you using ion, E-beam, or whatever in different locations depending on?
It depends on the application and the material. Not all materials can handle all the applications that we do. So it's customer application specific and material specific to what they use. Glass all looks the same, but they don't all act the same. Polymers all look the same, but they definitely don't act the same. That's why a lot of people went to polycarbonate for safety and protection. Acrylics are known to be very durable, but they do have their peculiarities about coatings. There's certain materials that we use. ZNX material is a very strong material used in optics. It's got very good properties for a lot of different things, and we have a tremendous success with that. We actually deal with a lot of the material suppliers to learn what their materials are coming down the pipe to qualify before our customers start using them for molding, diamond turning, polishing, whatever they're going to do. So we try to get in on the early side of the materials. And the same with customers. We try to get in before they dictate what the coating needs to be. So that way we can understand, well, if you do this, it'll help everybody because we can make it enhanced with this coating. So.
I was curious about that. How hand in glove do you work with customers? Is it do they rely on you for the coating and just hand it over to you, or do you work with them?
It sounds like a very consultative relationship.
It's very, very, very consultative. They don't necessarily specify coating materials and things like that. They specify reflectivity, durability, all that. And then we have to take into account the substrate and the coating materials and the environment it's going to be used in. That's a big key because somebody will tell you, oh, it's a very benign environment, and then you find out it's a very chemical-based environment, which will etch away certain things but won't touch other things.
Benign has many meanings.
One of the oldest materials in coatings is magnesium fluoride, mag fluoride coatings, and if you look at a lot of old camera lenses, they have a purplish blue hue to them. That's probably got mag fluoride either single layer or in the coating. It's a very, very successful coating material for a lot of durability. Although it needs a lot of heat, so it's not a good application for plastics. So there's other alternatives for plastics to get that protection coating.
And also in your capabilities, this is not manufacturing capability per se, but it's certainly value added. You also do quick turn prototyping.
Yes, we do quite a bit
Why is that
of
important
prototyping.
among your customers?
Well, usually by the time we get to the prototyping stage of actually creating a component, the project's probably been around months.
Yeah.
So they want to get some kind of result pretty quickly. So we have capability of 6 different coating machines. A couple of our smaller machines, and I'll call them smaller, they're in a 36-inch range, but they're very efficient on doing 1 or 2 parts.
Okay.
If that's all you want, but it's still a batch process. So we'll tell you what the batch is. We could probably fit up 50 more than you say, but we'll tell you what you can fit. If you make that many, you got it. If not, you get your 1 or 2 pieces in a relatively couple-week turnaround, which is great for prototyping.
Yeah, okay.
And we also offer some environmental testing and other applications that they want to make sure that they work preliminary in those applications, temperature, humidity cycling, temp cycling, salt fog testing, that kind of things.
Okay.
Which is important to a lot of applications. One of the newer applications that's coming out is AR/VR. And there's a lot of prototyping in that.
I bet.
We have a couple customers dealing with 3 or 4 prototypes at once, trying to dial in different things until they narrow in on exactly what they want. So we'll have 3 or 4 different batches going for the same customer. Sometimes knowing what they want, sometimes not.
Is this probably
offer
in a heads-up display?
Heads-up display,
Okay.
eyeglass type displays, because they're all trying to go smaller, right? They all want to be smaller, portable.
Yeah.
We've done half-face goggles. We've done eyeglass type stuff, and we've done micro-size stuff where it's implanted in a component.
Very cool.
I'm curious about the value chain of that because it seems to be that there seem 2, 3, 4, maybe 5 whales who are manufacturing these
absolutely.
things, and then everybody's trying to compete for their
There's a
business,
lot of
so-
fish
Is
that
there?
the whales eat, yes.
Well, that's
how they get to be whales.
There's been a lot of small entries in there, but yes, there's a lot of focus by about 4 or 5 main companies. And it's interesting. We know a lot of guys that started out from the old Kodak Optics group.
Yeah.
Now they belong to some of the larger social media type companies that are in the industry.
Yeah.
They're doing a lot of different applications for either AR, VR, driverless vehicles, imaging, thermal imaging.
Yeah.
It's funny how many different applications the same company will come to you about. It's like, okay, these are all different projects, and you're not going down the same road. So
I know AR/VR is getting a lot of the press. Is it the largest? Is that where most of the demand is being driven by? Or?
actually, I think right now, I would have said that 5 years ago. That was our big push. We had
Really?
the same 4 or 5 customers at the same time dealing with the same type of imaging.
Right.
And now it's more the driverless vehicle LiDAR
Interesting.
applications.
Okay.
And LiDAR is not just driverless vehicles, but it's traffic mapping, traffic tracking.
Yeah.
We do applications where we actually buy a component that's roughly about 7 inches, and it becomes a traffic LiDAR window over the camera system. So we're doing the front lens.
Gantry installations
Yep.
in that case?
Yep. So they came to us with a problem. They were using glass and they were using other things. We suggested this protected polycarbonate material with a anti-reflective coating optimized for their application. Added hydrophobic to it for cleanability and less damaging from water, and then it's working out really good for them.
Very good. And when we're talking about the LiDAR systems for automobiles specifically, I mean, we're not just talking EV. I mean, we're talking all the way across the board.
Yeah, general LiDAR.
Internal
I
combustion.
would call it general LiDAR. Those cars that have driverless applications in them, but there's still a driver in them.
Yeah.
Yeah.
Yeah, even if it's just self-parking, which is good because, the EV market's faced some headwinds over the last 12
absolutely.
months.
Yeah.
So a lot of people and just general manufacturing.
Yeah, a lot of people don't understand that a lot of the new vehicles coming out have those features in them for parking, crash protection, side view protection, backup.
So how many square feet do you have under roof right now? What's your production capacity?
We're about 12,000 square foot.
Okay.
We have 6 coating chambers. Right now, we run an extended first shift. We still have plenty of capacity.
Yeah.
We do a lot of prototyping, but we have a lot of high volume parts that run 30, 40, 50,000 parts through in a year.
Absolutely.
Those are mostly military and medical optics right now, and a couple in the LiDAR applications.
Gotcha. But is that kind of the holy grail, of your space right now? If you can become a primary supplier to Volvo's Tier 1, whoever's developing their LiDAR systems,
So we'll be downline from that. We'll be into their subcontractors that make a module that's going to plug into the car.
Okay.
Right.
So we've had those. Many of our applications have gone that way. So they end up in those Mobiles, Toyotas, those kinds of vehicles.
Do those represent volume increases of like an order of magnitude? I mean,
yes.
Is that what you've seen over the last few years? Because as you said, practically every vehicle has a self-parking feature or a pedestrian detection system.
That would be the next increase in production for us.
Yeah.
Like I said, right now our largest capacity is probably more towards the military medical applications.
Gotcha.
A lot of goggles, a lot of heads-up displays, imaging, gun scopes, those kinds of things. As you're familiar with, they just had the SHOT Show in Las Vegas, and that's a pretty big application for mini red dots, gun scope sights, that kinds of stuff. We didn't represent there this year, but we're thinking about going there in the future. So it seems to be it is a big application that we're already in.
Fantastic.
So.
Cool. With capacity to grow. So AccuCoat partner who can produce those volume as well as give that consultative final design development and optimization.
Yep.
So that's good.
Yeah, my partner and I have been together 25 years doing this, and he has over 35 years in coating design work, so on multiple materials.
Great.
Excellent.
Yep.
So 12,000 square feet. How many staff? Engineer.
Right now we have 25 staff. We have a quality engineer. We have a manufacturing production engineering. We have a process engineer who's an understudy to my partner, who's basically coding designs. So those two take care of that, and process improvements of vacuum chambers, updates, things like that, because we always have to keep them up to date. We have 3 machines that run on Windows 11, so you have to make sure you're always staying up to date with those things. Mark Cafori and
They're air gapped, just for the record.
Mark Cafori's director of new business development and sales, and then we have Sarah at inside sales and Melissa in the office.
Awesome.
And the rest is production staff.
And one chemical engineer. Is your partner? Or?
One chemical engineer, my partner. Yes.
I guess that's all you need. Okay.
Yes. Yep.
When you're doing this kind of production, is QA, quality assurance, is built right into it? I mean, are you testing are you doing batch testing? How does that go?
Well, spectrally for performance, we're testing every batch that comes out.
Okay.
We're testing a witness and or customer part if they require it and the system can handle it. Okay. A lot of their odd shapes, free forms, it's hard to measure spectrally for anti-reflective or metal coatings.
Right.
So we always have a witness piece along with the ride. And a lot of times now we have a witness piece along for the customers to prove it. So a lot of them need retention pieces, archive pieces, history, things like that. Yeah. I'd probably say about 40% of our jobs right now have a witness that goes back to the customer along with it to prove that our coating meets their specification. And we have retention pieces, and of course, because of applications, we have to keep them 5, 7, or 10 years, depending on the application. We have to be able to get back to those records for the customer.
Yeah, because a lot of the things you're doing are critical safety, especially when you talk military applications or automotive. Yeah,
a couple of our longest term programs are probably over 10 years in production, and they're more on the military optical side.
Interesting.
Yeah.
Where is the defense market right now? I mean, it's always around all the edges of everything that we do.
Yeah.
But the world's gotten a little bit more interesting, the last couple of years.
We've been using a lot of tools out there.
Yeah, I think it's been pretty stable the last 5 years, and actually we've seen a lot of growth the last year.
I wouldn't be surprised. Yeah.
A lot of growth in a pretty good magnitude, not just a few hundred extra parts here or there. We're talking multiples of what we used to do.
Yeah, been having to replace a lot of stocks here just in the U.S.
The biggest shift is because they're going to lighter, more durable parts. Right. So a lot of our expertise is in the plastic polymer optics. So a lot of our components that we've done long-term history for military applications are polymers, the ZNX, the polycarbonates, the OKP products, those kinds of things.
Type applications.
Yep. So they make them a lot lighter, a lot more durable, and they can keep going.
Do drones play a role in that? In your technology?
Drones play a role more so from the the only application I know that we've done drones is more in the LiDAR, the mapping, those kinds of things. Or you'll see the camera hanging below the drone, protective lenses, and that type of stuff. Yeah. That's where our applications have been used.
Those lenses have to be a little larger too, though, correct? To cover more ground, fewer passes.
Yep. They're basically a 4 to 6 inch lens cylinder. Those are basically the cylinder lens systems. And either they're used on the vehicles or mainly right now I think they're used on the drones.
Interesting.
Because they'll carry the camera system up there. A lot of it's just a protective lens to prevent anybody from seeing what's inside and any stray light from getting inside. It'll basically be a black dye lens,
Right.
because it doesn't need to work in the visible region. Your eye only sees out to about 700 nanometers.
Right.
Those cameras are working out 900,000 nanometer range, so they could be dark. The laser will still go through them.
Excellent.
Yep.
Cool. I know it's only the first day of Photonics West here.
Yes.
And it's the morning, so you probably haven't had a chance to do the whole floor. But I'm curious, what do you see looking ahead? Is there anything on the floor that's kind of caught your eye, or the show, or what do you see in the
Actually, I was pretty impressed the first couple hours of the traffic flow already.
Yeah.
And the size of the show, the size of the booths and stuff, and the imaging, it looks like a lot of what I call the forefront companies, the investment they put out there shows me that, okay, they're knowing that we're moving ahead, we're going to move forward. It's been different over the last 5 years.
It sure has.
We've had a tough 5 years, and 2023 was a big comeback year, and then this year we're looking for even a bigger. Last year was really good for us. I wasn't at that show, my partner was in the sales staff.
Yeah.
And then this year's already looking pretty good.
No, macroeconomic indicators are looking up. So
Yes, absolutely.
That's a good sign.
Yep.
Although a lot of the industries that you're working in, medical device, defense, and others, kind of
Right.
exist outside of normal cyclical stuff.
Unfortunately or fortunately, during the bad 5 years, those markets were doing still pretty good. So
Yeah.
our business actually did not suffer during the 5 rough years we've had here. But it was interesting because we do a lot of medical and military, and the way we're set up and clean, that we were able to stay operational pretty much straight through everything.
Yeah, essentially. Well, I mean, most manufacturing companies actually did. Well, if you could get components,
If you could get components,
if your
yes.
supply chain didn't fall apart
After your first year, if you could get components, you were successful.
absolutely.
Yep.
Absolutely.
Actually, we were very fortunate because of the materials we buy are very low volume.
Mm-hmm.
We'll buy a 500 kilogram bottle,
No kidding.
and it'll last a pretty long time.
Yeah.
We are using grains per run. We're not
films.
using scoops, so not like scooping your coffee. We're putting a few grains in there every few runs. Clean up, repot. And then our material. A couple substrates we purchase, very limited substrates, plastics or glass, some flat stock stuff. We don't buy any custom. But those took a little bit of delay, but everything else we stayed pretty much on course. Now, we did buy ahead a little bit during that time because we're banking on some issues coming, but fortunately we actually survived pretty good. Some of our component manufacturers did not. Right? Glass supply slagged, plastics,
Germanium.
Germanium's definitely, that's still an issue.
Yeah.
Right.
A little bit of an issue. That's why more people are looking towards chalcogenated alternatives if they can.
Which you also coat. Yeah.
If the application,
So the supply chain issues are more substrate based
Yes.
rather than coating based.
Yep.
Right. And most of the substrates are coming from overseas, correct? Well, it depends on which one you're looking at, of course.
Some of them, yeah. I would say we're still about good percentage in the U.S. Okay. There's a good percentage of the glass manufacturers are overseas, yes.
Okay.
Yeah, that would be downline from us. So we buy from a finishing fabricator, or we get our parts.
Okay.
They get their parts from the glass supplier, who then gets it from the raw material stock. So.
But the deposition materials, those are almost all here.
No, actually, almost all our depositions come out of Europe.
Okay, no kidding.
All our materials come out of Europe, even some of our cleaning line materials.
Interesting.
So we have to prepare for that, but we've been very fortunate with that.
Huh. And why is that the case?
Just where the source of the material is in the companies.
Okay.
Like you said, the whale buying the fish.
Right.
So that's where they've all ended up.
Gotcha.
Germany's a big
Yeah.
area where coating started, and all
Through
that
glass.
development of materials. Germany and Switzerland. So that's a big source of a lot of our stuff.
Wow,
now they have local reps or local warehouse, but
Of course.
it's obviously beginning overseas.
Right.
Right.
Yeah.
Well, that's a good thing. Which those are friendly nations.
But we didn't get jeopardized like when cerium oxide had their issues of polishing materials. They had long delays or availability because of the countries they're coming from.
Right.
We didn't experience that. We just experienced that we didn't get product that used that material to get to us. So we saw a slowdown in that. But
Right. Well, at least your portfolio is diverse enough in the
yes,
applications.
we're very diverse. Very diverse for a small company. Like I said, we're 25 people. We've been around quite a while, but we have very diverse applications.
Yeah.
And it's very interesting. Usually when one part of the industry is slacking, the other one's probably picking up and moving ahead. And then, it's always nice when you see new prototypes, research coming out, because that's where the next round of stuff is going to come from.
When you were talking about AR and VR earlier, do you have any kind of insight into what are the end user markets those are going into? I mean, is it in industrial operations maintenance, MRO type applications? Is it obviously defense?
Obviously defense.
You mentioned that.
Some
Consumer
of the bigger
electronics?
ones we've worked on are probably not defense.
Yeah.
A lot of them go into commercial industrial applications first to try them and test them, and then they move over to the defense world.
Gotcha.
Some of the strange, peculiar applications, those are definitely coming out of defense. They're really trying to push the limits before anybody else.
Right.
But a lot of the general applications we do right now are more in the commercial industrial.
Give us an example.
Vision inspection for people looking at equipment.
Yeah.
We saw one application where it was a AR/VR application of creating goggles where software engineers can all work on the same package at the same time, but they can see what's going on in the goggle set.
That's interesting.
Game imaging. Gaming.
That's kind of what I was wondering,
world.
whether consumer electronics was finally starting to see significant volume uptake.
Yeah, they are starting to see a very,
kidding.
very big application. There's a couple larger companies, nameless, that are really driving that. In various ways.
Yeah.
Either they purchased and or developed from scratch.
Yeah. Yeah. Well, I'm an AR/VR geek for sure, so I find that stuff
As a
interesting.
matter of fact, they got that show, and hopefully I'll get over there Thursday to see some more of what's going on over there. I just saw some setup yesterday, but not much going on.
It should be interesting for sure.
It is pretty interesting what they're doing over there. What's going on with that.
And then next year, that's going to be paired with machine vision. Is that right?
Yes, that's right. Well, it's the
Vision.
same building. Yeah,
Same building.
Actually, it's the same floor.
Machine Tech,
Yeah,
Vision
it'll be
Tech, whatever it's called. Yeah.
Vision Tech.
Yeah, same
That's
floor.
right. So
Same building.
you have plenty of work to do over there.
Yes.
When you're not in your
yes.
booth.
It's nice to see this commercialized.
Actually, I think the
show.
show's getting big enough where we need to bring more people out. We usually have 3 people here, so it's getting to a point where you almost need to have extra people so you can rotate and get out and stuff like that more so,
Especially if you want to go meet any partners out on the floor.
Yeah. I don't know if I want to get to that 20-person staff here, but
well, if you do, you're making so much cash.
Yeah,
it's
I
all
know.
good. It's
Yeah,
a
it's
beautiful
all right.
thing,
It's all good.
Right? It's all good.
All right.
Awesome.
Patrick, really appreciate your time.
Thank you very much. Thanks for the opportunity to talk to you guys. Appreciate it.
It's our pleasure.
It's our pleasure. And for all of you listening, this is Manufacturing Matters Podcast. If you'd like to join us, look us up on LinkedIn. If you'd like to view more of our episodes or this episode when it comes out, you can find us on www.manufacturing-matters.com.
That's correct. And if you got any questions for Patrick, be able to just look them right below there. We'll make sure it gets to Patrick, or go to AccuCoat.com. And I'm pretty sure you can get a little faster response, but whatever we can do. Until next episode, thanks for joining us.
Thanks for listening.
Thank you.